Hi guys, this is AS Chemistry, Organic Chemistry, and we are looking at properties of organic compound. Question 1. Which organic compound has the highest boiling point? So A is a carbon atom bonded to four CH3 groups. B is a straight chain alkane having 1, 2, 3, 4, 5 carbon atoms. C has a CO group, which is a ketone group in its structure, and D has an OH group in its structure. So A and B are alkanes, C is a ketone, and D is an alcohol. Now, alkanes would have London's dispersion forces present between the molecules, and the longer the exposed surface area, or the greater the exposed surface area, the higher the boiling point. So B has a higher boiling point than A. If we compare C with A and B, C has a C double bond O group present, which has difference of electronegativity in it, which means molecules of C would have permanent dipole-dipole attractions present between the molecules. So because of a stronger intermolecular force of attraction, the boiling point of C would be greater than that of A and B. And in D, we've got the OH group. The OH group can interact with another OH group via hydrogen bonding, which is the strongest van der Waals force of attraction, which means that D would have the greatest boiling point out of the four structures present, because hydrogen bonding is a very strong intermolecular force of attraction and would need more energy in order to be overcome. So the correct option for this question is option D. Question 2. Which compound has a boiling point that is influenced by hydrogen bonding? So A has a CHO group, which means it is an aldehyde, and an aldehyde has a C double bond O group, which has a difference of electronegativity. So it would have permanent dipole-dipole attraction and not hydrogen bonding. B is an ether with a CH3 group bonded to an oxygen atom bonded to another CH3 group. This is a non-polar molecule and will have London's dispersion forces present between its molecules. C is an ester because you've got H, C double bond O, single bond O, and CH3. This would also have permanent dipole-dipole attractions present between the molecules. And D is a carboxylic acid, which would be HC double bond O, single bond OH. Due to the presence of this OH group, molecules of D would interact with each other via hydrogen bonding, and that is what is asked in the question, making option D the correct option for this question. Question 3. In which pair does the second substance have a lower boiling point than the first substance? So in A, we've got C2H6 and C2H5Cl. Now, since a hydrogen atom is being replaced by a chlorine atom, the MR increases. Because the MR increases, the boiling point of the second substance is higher than the first one. In the case of B, the first compound is an ether, the second is an alcohol. Ether would have London's dispersion forces present, alcohol would have hydrogen bonding present. Hydrogen bonding would cause the alcohol to have a higher boiling point than the ether. In C, we've got neon and argon. Both are noble gases. Argon has a higher AR than neon, so argon would have a higher boiling point than neon. In D, CH3NH2 is an amine which would have hydrogen bonding present between its molecules, while C2H6 is an alkane which would have London's dispersion forces. So London's dispersion forces are weaker than hydrogen bonding, making C2H6 a molecule with a lower boiling point than CH3NH2, which makes option D the correct option for this question. Question 4. An organic molecule W contains 3 carbon atoms. It requires 4.5 molecules of oxygen for complete combustion. What could W be? So we've got propane, which has a molecular formula of C3H8. We've got propanoic acid, so this would be C3H would be 6 and O2. We have propanone C3H6O, and we have propane one all C3H8 and O. So now we need to find out which of these has a requirement of 4.5 moles of oxygen for complete combustion. So For propanone, the requirement would be x plus y upon 4. So 3 plus 8 upon 4 is equal to 8 upon 4 is 2 and plus 3 is 5 moles. So for propanone, we need 5 moles. For propanoic acid, we have got C3H6. So it would be 3 plus 6 upon 2, which would be 3 plus 3, and then we minus 1. So it's 6 minus 1, which is equal to 5 moles of oxygen required. For propanone, it would be C3H6 and O. So this would be 3 plus 6 upon 2, which would be 6, minus half would be 5.5 moles of oxygen required. And in propane one all, we have C3H8O. So this would be 3 plus 8 upon 4. 8 upon 4 is 2. 2 plus 3 is 5. 5 minus half, because one oxygen is already present, would give us a requirement of 4.5 moles of oxygen, making option D the correct option for this question. Question 5. What is true of every nucleophile? It attacks a double bond. No, it is attracted towards a positively charged uh, atom. It donates a lone pair of electrons. Yes, a nucleophile must have a lone pair of electron present in order for it to be called a nucleophile. It is a single atom. No, it can be a molecule as well. It is negatively charged. A water molecule is not charged at all, but is a nucleophile. So is ammonia, which does not carry any charge, but is a nucleophile. So a nucleophile donates a lone pair of electrons, making option B the correct option for this question. Question 6. Four compounds are shown: C2H4, C2H5OH, CH3CHO, and CH3COOH. How many of these compounds have an odd number of sigma bonds? So, in order to count the number of sigma bonds, we need to draw the displayed structures. So, C2H4 would be drawn this way. Then we would have C2H5OH, which would be drawn in this way. Then we have CH3CHO. So CH3CHO is represented this way in its displayed formula. And the fourth one is CH3COOH. So CH3COOH would be displayed in this way. So these are the four different structures of the four organic compounds given as options. Now to count the number of sigma bonds present. So in option A, we have 1, 2, 3, 4, and 5. We've got 5 sigma bonds present in option A, or rather in the first option. A, B, C, D here would represent the number of molecules that have odd number of sigma bonds. So the first compound given, C2H4, has an odd number. So let's place a tick here. Then we have C2H5OH. So 1, 2, 3, 4, 5, 6, 7, and 8. So C2H5OH has an even number of sigma bonds present. In CH3CHO, we have 1, 2, 3, 4, 5, and 6. This also has an even number of sigma bonds present. And in CH3COOH, 1, 2, 3, 4, 5, 6, and 7. So this has an odd number of sigma bonds present. So in total, we've got two molecules having an odd number of sigma bonds present, making option B the correct option for this question. Question 7. Ethanol, CH3CHO, ethanol, C2H5OH, and methoxymethane, CH3OCH3, are three organic compounds. Which compound has the highest boiling point, and what is the interaction that causes the boiling point to be the highest? So ethanol has permanent dipole-dipole attractions present. Ethanol will have hydrogen bonding present, and methoxymethane would have uh, London's dispersion forces present. So highest boiling point would be that of the compound having hydrogen bonding. So methoxymethane having permanent dipole-dipole forces. This is incorrect. Ethanol having hydrogen bonds. Ethanol will have permanent dipole-dipole attraction. So this is also incorrect. Ethanol having hydrogen bonding, yes, hydrogen bonding is the strongest van der Waals forces of attraction. And ethanol, which has permanent dipole-dipole forces, the forces represented is correct, but this is not the strongest intermolecular force of attraction. So this makes option C the correct option for this question.